Okay, so let's try just a rando example to illustrate how polar is going to help. So suppose I wanted to integrate over the unit disk, x squared plus y squared d area, right?
Okay.
Okay, so first things first, make yourself a picture of the region you're integrating over.
It's a circle. The origin, correct?
Unit disk filled in. I guess we may as well make this the unit disk including the boundary. Cool. That, by the way, is a standard symbol for the unit disk. So if you see that somewhere else, that's what it is.
Okay.
So here's my unit disk with the boundary filled in. What's the radius?
1 or
1. Because it's a unit disk. Thank you. Okay. How do I set up this integral? You need to pick a variable to integrate first, right? So I'm thinking to myself, okay, it's going to be a double integral. There's going to be an x squared plus y squared, right? The function I'm integrating. And then there's going to be a d and a d. Yeah, you guys see that? It doesn't really matter. I'm going to look at this thing for a second and think, which way makes more sense to me? Do I integrate this way or that way first?
Doesn't matter because there's.
Yeah, it's totally symmetrical, right? But for some reason in most of your minds, I think this one makes more sense.
Yeah, because it's a function.
dy to dx.
Yeah, there's like vertical line test that tells you that this shit isn't a function or something. Right? There's also a horizontal line test which tells you this shit doesn't have an inverse function. Whatever. Okay, so if I'm looking at these things, I'm thinking integrating dy first, right? So I'm thinking dy dx. Okay, so where do the y's range from? Ooh.
But it's a function, it's not
This
just
is
a...
square root of 1 minus x squared negative to the positive.
Ooh, you guys see that? If I did negative 1 to 1 and negative 1 to 1,
You'd get a square.
I would get a square. But this thing isn't a square, right? The y's start at the bottom and go to the top.
So you just solve for y then?
Yeah, it's.
Yeah, so I need to figure out where the y's range. And so I might remember that the unit circle is x squared plus y squared is 1. And so then I think, okay, well, if x squared plus y squared is 1, y squared is 1 minus x squared. And so then y is the square root of 1 minus x squared, right?
Plus or minus.
Yeah, except it's not, because it's plus or minus that.
That just needs boundary.
Yeah, those are my bounds, right? Because the minus root 1 minus x squared is the bottom half, and the plus is the top half. You guys see that? So I want to go from the square root of 1 minus x squared to the square root of 1 minus
X.
Still x squared.
x squared.
And the
What did I
bottom
just screw up?
The
Negative
bottom
on the
one.
bottom side.
The bottom one needs a negative sign.
And then the x's can have 1 to 0.
Negative 1.
Negative 1.
And the x's
Oh, sorry.
go from negative 1 to 1, right?
Sorry, the bound is already taken into account.
You guys follow that?
Yep.
That's gonna be nasty.
Okay. Question, why is this going to be nasty?
I think we could just kind of look at how we're going to integrate and it's going to...
Okay, so let's try, just for kicks. Let's try integrating.
Alright.
So, I'm going to get an integral from negative 1 to 1, right?
X squared y.
Of x squared y plus
1/3 y cubed.
y cubed over 3, evaluated from minus the square root of 1 minus x squared to plus the square root of 1 minus x squared. And then I need to evaluate that dx, right? Shit. Right? Okay, so you get the integral from minus 1 to 1 of x squared times the square root of 1 minus x squared plus the square root of 1 minus x squared cubed over 3 minus,
In parentheses.
oh, but wait, hang on. When I put the minus 1 in there, what do I get out? I get the same thing again.
Yep.
So I can exploit symmetry a little bit. I could probably have actually exploited symmetry a little more, because I could note that this function's symmetrical in both x and y. So I could slim this down to the first quadrant and then multiply by 4. That's a little bit varsity, so if you didn't see it, you didn't see it. Don't worry about it. How are you gonna, oh, what did I forget? What did I lose?
The minor.
I lost the dx, thank you, which becomes crucial here, right? Like in Calc 1, it didn't really matter if you didn't have the silly thing.
Oh, it did.
That's like a.
So you lost points, right? But did you get the answer wrong?
No.
Not in the end.
Probably not. Here, if you lose those things, God knows what variable you're integrating with respect to, right? Or which order things are happening in. And it's crucial that the order be right. Because otherwise you'll end up with a function instead of a number. You guys all see that?
In which case you backtrack and then.
Yeah, in which
know.
case you need to backtrack and sort it out, which takes forever. So, how do you do this stuff?
Oh boy, we still have to do the integral of 1
Let me know if they integrate it first. Good luck with that.
Oh, first we say u equals x squared.
Yes.
Oh, but then we don't have a du.
Only have 1 minus x squared.
Oh my gosh.
Oh, hang on.
Oh,
no. Triangle time.
Which, yeah, Merrill, I think, calls triangle time. Okay, good news. You can totally avoid that shit here.
Yay.
Really?
Bad news. You have to learn how to convert to Poland.
Dang.
So, let me abandon this. And then let's learn to do Poland.
Following it.